everyone. Today we're going to solve another supplementary problems in Chapter 6, Fluid Flow Measurement from the book of Gillesania, Fluid Mechanics and Hydraulics 4th edition. So here we have problem 6-74. The truncated cone shown as theta is equal to 60 degrees. How long does it take to draw the liquid surface down from height of 5 meters to 2 meters? So first, let's identify our given. So we have here the angle of 60 degree and height from 5 meter to 2 meter. And based on the given figure, we have here the diameter of 1 meter and also the diameter for the opening, which is equals to 80 millimeter converted to meter, which is equals to 0.08 meter, and coefficient of discharge, which is equals to 0.80. Since we are looking for the value of time, we're going to use the formula of discharge, which is equals to volume over time. Deriving this equation, we can get dV is equals to dQ times dt. Since Q here is unknown, we can use the formula of actual discharge, which is equals to coefficient of discharge times theoretical discharge. Since theoretical discharge is also equals to area times velocity, we can equate this to our formula. So deriving this equation, we can get dQ is equals to coefficient of discharge times area times velocity. So additional information, the volume of cylinder is equals to pi r squared h, and area of a circle is equals to pi d squared over 4, and velocity in a fluid flow is equals to square root of 2gh. Substitute are given to our formula. So we have here dQ is equals to coefficient of discharge times the area times the velocity. Since the area of a circle, which is equals to pi d squared over 4, and the velocity of fluid flow, which is equals to square root of 2gh. So substituting the formula, which is we have here 0.80 of this for the discharge, coefficient of discharge, times pi times the quantity of 0.8 squared over 4 times the square root of 2gh. So we have here the first equation. And to solve for the radius based on the given figure, we have here tan theta or tan 30 degrees is equals to r minus 0.5 times height. So equating this formula, we can get the value of radius, which is equals to height over square root of 3 plus 0.5. And substituting the radius to our volume, which is equals to pi r squared times height, we can get volume is equals to pi times the quantity of h over square root of 3 plus 0.5 squared times height. Deriving this equation, we can get dB is equals to pi times the quantity of height over square root of 3 plus 0.5 squared dH. And we now have the value of dV and dQ. We can substitute it to our given equation. And since it is going downward, the velocity is negative. Negative dV is equals to dQ dt. Substituting the value of our dV and dQ, negative pi times the quantity of h over square root of 3 plus 0.5 squared dH is equals to 0.80 times pi times the quantity of 0.08 squared over 4 times square root of 2gh dt. And equating this formula using FOIL method and multiplying both sides by 1 over pi to cancel the pi in both sides. So we now have negative h squared over 3 plus h over square root of 3 plus 0.25 dH is equals to 0.80 times 1 over 625, and separating the h to be transposed in this side, it will become square root of 2g times square root of h dt. Multiplying both sides by 1 over square root of h to combine like terms, we now have negative h squared over 3 times the quantity of square root of h plus h over square root of 3 times square root of h plus 0.25 over square root of h dh, which is equals to 0.80 times 1 over 625 times square root of 2g dt. Simplifying this term, we can get negative h over 3 halves over 3 plus square root of h over square root of 3 plus 0.25 over square root of h dh, which is equals to 0.80 times 1 over 625 times square root of 2g dt. And integrating this equation with the limit of 5 to 2, we can get 10.32, which is equals to 0.00567 t. So to solve for t, divide both sides by 0.00567. T is equals to 1820.97 seconds. Converting it to minutes, we can get t is equals to 30.35 minutes.